we left off at our unit circle. And what I'd like to do to start with the unit circle is to revisit our quadrantals. Remember, our quadrantals are the points that occur on the axes. So here we had 1 and 0, 0 and 1. This was -1 and 0. And here is 0 and -1. Do we agree on that?
Yes.
Okay. Now, what I'd like to do is take this a step further within our unit circle. We know the following angles in the first quadrant. We know that this is 30 degrees, 45 degrees, and 60 degrees. Do you agree? Okay. We also know ordered pairs are listed as X and Y. You agree? Okay. Now, what we're able to do in the unit circle, what is our R value? 1. Okay. Our R value here is always going to be 1. Now, what I'd like to do is real quick, let's relabel what our 30, 45s, and 60s are in terms of radians. Do you recall 30 degrees was how much in radians? Pi over 6. And this was pi over 4, and then pi over 3. So with that first quadrant filled in, what I'd like to do is just kind of backtrack for a second and look at special right triangles. Special right triangle. Oops. Whoa, I'm screwing this all up. I wouldn't put it on the unit circle itself. This is how we're going to create something. Let's say it's a 30, 60, 90 triangle. When we did the 30, 60, 90 triangles, we were able to figure out that across from the 30 was a value of 1, across from the 90 was the value of 2, and across from the 60 was how much? Square root of 3. You remember that? Now, what is the sine of 30 degrees? 1 over 2. Opposite over hypotenuse. It's 1/2. What is the cosine of 30 degrees? Root 3 over 2. Okay. Now, let me just ask this real quick. Sine of 30. Sine of 30 is the same thing as pi over 6, right? 30 degrees is the same thing as pi over 6? Do me a favor. In your calculator real quick, just so you guys can see that this does work, make sure you are in radian mode real quick. Remember how to check if you're in radians? Hit the mode button. Hit the mode button, and then I want you to hit sine of, and open up parentheses, hit pi divided by 6, close the parentheses. Is this not opening? There you go. Yeah, remember how to check to see if you're in radians? Hit the mode button. I'm just taking a second to load this up here. I know, but I want to show you, to make sure that, so you guys see that it does work. Remember, hit mode, make sure you're in radians. Okay? Now, all I want you to do is type in sine, hit pi. Oh, that's even. Where's the pi button? Oh, there it is. Over 6. With any luck, you get 1/2. Okay? Remember, pi over 6 and 30 degrees means the same thing. 1 degrees, 1 radians. They should have the same sign value. Okay, they should have the same sign value. What? Are you in radians? You're not in radians then, are you? Hit mode. Thank you, Liza. So, we agree that sine pi over 6, cosine of pi over 6 is both 1/2. Let's do the same thing. Sine of 60 and the cosine of 60. The sine of 60 is how much? root 3 over 2. Cosine of 60 is 1/2. Everybody okay with that? 60 degrees was the exact same thing as saying pi over 3. Okay? So with any luck, when you hit cosine of pi over 3, it should also spit out 0.5 for you in your calculators. Unfortunately, your calculator will not spit out root 3 over 2. Does anybody have a multi-view on that? I don't know if the multi-views do that. Sine one. Awesome. Yeah. Oh yeah, it does. That's awesome. No, you won't, because when you get into the tests and quizzes on a lot of this stuff, you're not going to be able to use a calculator. Anyway, now as we go through this, I want you to remember ordered pairs. Your ordered pairs go x, y, correct? Remember, the cosine was always the x value, the sine was the y value. So now as we start to look at this, let's backtrack to the unit circle. As we backtrack to the unit circle, as you backtrack into the unit circle, you should be able to find out some interesting things. Which means that we're going to be able to find our sines and cosine values, our x's and y values, throughout the entire unit circle. Remember, the x-coordinate is the cosine, the y-coordinate is the sine. So I know that the the cosine of 30 degrees root 3 over 2. I know that the sine of 30 degrees is 1/2. What do you think the ordered pair is going to be for? No.
Wait, well, one's x and one's y.
Remember, it goes. I lost my pen. I'm doing 30. Starting with 30. Remember, it goes cosine, sine for x's and y's. Okay. So this would have been root 3 over 2, comma 1/2. Okay. As we go up to the 60 degree, what was the cosine of 60? It's 1 over 2, and then root 3 over 2. It is. Yeah. Okay. Now, the 45. When you're working with a 45-45-90 triangle, it was just a pretty similar. You had to remember your special sides. So if we go back to a 45-45-90, just for real quick, if I was at a 45-45-90, we said that it was 1, 1, and root 2. Remember that? So the sine of 45 was 1. The sine of 45, which is the same thing as pi over 4, is 1 over root 2. And what do you do to that? Yeah, we just write it as root 2 over 2. What's the cosine of 45? It's the same thing. It's root 2 over 2. Okay? Sine and cosine of 45 degrees, or sine and cosine of pi over 4, are the same thing. Root 2 over 2. So that means that my ordered pair at pi over 4 is root 2 over 2, comma, root 2 over 2. Okay? Everybody with me so far? Now, from just knowing those 3 ordered pairs, bless you. God bless you. as you know, as you can find these three ordered pairs, the other sets of three mirror it. And here's why. If I was to draw a horizontal line to that point, what do they share in common on that horizontal line? Same y value. They share the exact same y value. Now that means, oops, moved the wrong one, sorry. If they're sharing the same y value, that means that this ordered pair has what for us a sign? 1/2. Okay? As you go from here to here, well, let's label out our next angle here. It was 30, 60, here's our 90, which was pi over 2, 120, 150, no, I'm sorry, 135, 150. As we go through our radians, remember we're adding a 6, so that was 3, so that's 4 pi over, so it's 2 pi over 3. Do we agree? This one was, what? 3 pi over 4, and 5 pi over 6. So, what I want you also to notice is that the ordered pairs themselves are the same. Do you see how we go to the left, -1, go to the right, +1? In the second quadrant, what values are positive and what values are negative? X is what? Positive or negative? Negative. So that means that the ordered pair here is going to be negative √3 over 2 and 1/2. Okay? Because in the second quadrant, your x values are negative, your y values are positive, which means your cosine values are negative, your sine values are positive. Second quadrant is negative, positive. Third quadrant, they're both negative. Fourth quadrant, it's positive and negative. Okay? Now, let's go from this point here vertically downward. We know that this is at pi, 180. Add another 6 to the pi, we got, 7 pi over 6 at 210. 225. 225 was 5 pi over 4. And then 240, and that was 4 pi over 3. So follow this vertically down. As I'm going vertically down, does the x value change or the y value change? The y value changes. The y value changes now, but the x value stays the same. So that means my cosine is the same as it is here, negative √3 over 2. But now my y value is just mirrored 1/2, but is the 1/2 going to be positive or negative in the third quarter? It's negative. So there's your ordered pair there. Is it starting to make sense why you only really need to know 3 of these? Because everything else just mirrors itself around by making a rectangle. Go across. I go across again. As I fill in my blanks here, we are at, this is what, 3 pi over 2, 270, 300, which is 9 pi, no wait. 5 pi over 3. Then we have 7 pi over 4. And then 11 pi over 6. So 300, 315, 330. Do we agree? As I come back across this way, notice I am staying horizontal, so my x value, my y value is going to be the same. And my vertical here, my x value stays the same. So I'm at positive √3 over 2. and negative 1/2. And all I did was walk around the unit circle for every angle that has a reference angle of pi over 6. Okay? Every one of these angles has a reference angle of pi over 6, or if you will, 30 degrees. All right? Now, the other 6 ordered pairs, the other 6 ordered pairs mirror themselves out, just changing signs. So I know that pi over 4 is root 2 over 2, root 2 over 2, root 2 over 2. That means that at 3 pi over 4, what is the ordered pair? Very good. So it's negative root 2 over 2, root 2 over 2. At 5 pi over 4, they're both negative. And then at 7 pi over 4, it's root 2 over 2, negative root 2 over 2. And then you do the, once again, for the pi over 3s. As you go around with the pi over 3, you are negative 1/2, root 3 over 2, negative 1/2, negative root 3 over 2, and positive 1/2, negative root 3 over 2. And that gets you all the way around the circle. It is important to be able to know the first quadrant. If you know the first quadrant, you're gold. Okay? One real easy way to remember this. If you look at these ordered pairs, look at the x-coordinates. 3, 2, 1. Y-coordinates, 1, 2, 3.
And
They're all over 2. Everybody see that? 3, 2, 1. 1, 2, 3. If you look at the ordered pairs, if that's an easy way to help remember it, it's an easy way to remember it. 3, 2, 1. 1, 2, 3. And once you know that one quadrant, just remember how everything mirrors itself going all the way around the unit circle just by using the rectangles. Okay. Now remember, we talked about what quadrants things are going to be positive and things are going to be negative. So you have to remember, you have to be able to tell what the reference angle is going to be by walking around the circle and bouncing back and forth to figure out what quadrant you're in. That should not be so bad, though you're looking really hard to find the right. Okay? Do we all have that filled in? Lovely, lovely diagram. That'd be a pretty big BA tattoo. I almost said it. I'm sure some math nerd has that tattooed somewhere. No. All right, questions? So here's what we're going to be able to do with this. Here's what we're going to be able to do. We are going to be able to figure out what the tangent of negative 210 degrees is by using just our unit circle. If I'm using my unit circle, and I want to figure out what the tangent of negative 210 degrees is, I first have to figure out where negative 210 degrees is. So, we find the reference angle. We come around, we go negative 180 and 30 degrees more. So this is up 30 degrees here, which means the reference angle is at what? 150. Do we agree? So my reference angle is at 150. My ordered pair, my cosine sine, at 150 was and 1/2. Tangent is y over x. Do you agree? So that means it's 1/2 divided by negative root 3 over 2. So you just multiply by the reciprocal. Remember, this is x, this is y. Tangent is y over x. It's a complex fraction. Rewrite it. You wind up with negative 1 over root 3, which is negative root 3 over 3. There's your tangent. Right? What you're going to be doing is working back and forth off of your unit circle to find reference angles. As you come back and forth off those reference angles, that's what's going to allow you to figure out your x's and your y's, and you'll have to go back and forth off of that. We'll do another one here in a second.
Okay, so you switch the.
Cosecant of 11 pi over 4. Cosecant of 11 pi over 4. Which means we first of all have to figure out where in the world are cosecant of 11 pi over 4 is. So we got to figure out what 11 pi over 4 is. 4 goes into 11 how many times? Twice. How much is left over?
3.
Okay. So this is the same thing as 2 3/4 pi. Do you agree on that?
Yeah.
Okay. So here is 1 pi, 2 pi. That's half a pi at 90 degrees. Remember that? So here's my 4th pi. So that's pi over 4. So that means this theta is how much? Well, 90 and 45 was 135. So that's what, 3 pi over 4? Convenient. What's the ordered pair then? Root 2 over 2. Root 2 over 2, and which one's negative? Okay. What's that? Now, we know that for the unit circle, what's your R value? 1. Cosecant is R over Y. It's the inverse of sine. Remember that? So, 1 over root 2 over 2 is 1 divided by root 2 over 2. So that's 2 over root 2, which is 2 root 2 over 2, which is root 2. It's just a lot of flipping around of fractions. It's a lot of flipping around of fractions. Or just remember, cosecant is the inverse of sine. Here's your sine value, root 2 over 2. Flip it, rationalize. And there's your answer. Okay? What I want you to do tonight is all about these exact same ideas, these same problems. It's on page 389. No, yeah, 389. On page 389. Not 389, 789. Hello. I want you to do all of those. It's all the same idea of those first couple examples I just gave you guys. Find the reference angle, figure out what it is, look at your ordered pairs on your unit circle, get in the habit of writing out of drawing the reference angle, getting the ordered pairs and going. Okay?